Hi students, welcome to exercise 31, the multiplicity and vertical stretch of polynomial functions. Alright, so let's take a look at this graph here in A. This is y equals to x minus 1 squared. You would have seen this graph before in probably grade 11 pre-cal. So basically, if you look at it in terms of transformations, this would just be the x squared graph moved 1 to the right. So what you have is you have a 0 at 1, and you'd have the regular function, the parabola like this, and you'd have that parabola. Okay. We also call this, when we talk about polynomial functions, we talk this as being a multiplicity of 2. So in this function, there's a 0 at x equals 1. There's only one 0, and we call the 0 with a multiplicity of 2 because there's two of them, right? This means the factor x minus 1 is repeated twice. Okay. So something to recognize and to note is the graph remains positive on both sides of the zeros. So we call this a bounce, you could call it as well, at the x equals 1, 0, is that we bounced on the 0, 1 because of the square function. Alright, so now let's say we had b, we had y equals x plus 2 cubed. Okay, so again, this is our cubic function that we've seen. Cubic function looks like this, and it's moved over 2 to the left. So the 0 would be at negative 2, and we would have this kind of half parabola this way, half parabola that way, and you go up. Okay? So we call this 0 at x equals minus 2. It has a multiplicity of 3. Okay, so in B, the multiplicity of the 0 x minus 2 is 3. So the factor is repeated 3 times. And when I say 3 times, what you could have written this. Right? Because it's just cubed. So you could have wrote it out 3 times, so the factor is repeated 3 times. There's a shape associated to a multiplicity of 3. Okay, it's the same shape as a cubic function. So if you have a 0 with a multiplicity of 3, what you're going to see is you're going to see this shape appear. Alright, so you're going to have this little half parabola one way, half parabola the other way. Multiplicity of 2, you bounce. Multiplicity of 3, you're going to have this kind of odd shape coming around the 0. Alright, so now what does that look like when you have more than one factor or more than one 0? Okay, so this is a cubic function. The reason it's a cubic function is because this factor is twice, right? Multiplicity of 2, and this has a multiplicity of 1. So if you multiplied all that together, you would get a cubic. A cubic means power of 3. So a cubic function is an x cubed function, which has this shape, right? Which means that you're gonna finish here and start over here. Okay? Your zeros are x equals negative 2. So I'm going to put my negative 2 here. And we have x equals 1 is my other 0, right? So x equals negative 2, x equals 1. So that's where your zeros are going to be. Okay? And now, since we know that the graph must end here and start here, we can sketch a graph. Notice that we're going to bounce at x equals 1 because the multiplicity of 2 here. So what the graph's going to look like is it's going to start over here, it's going to come down, but it's going to bounce at x equals 1. Okay, so this is the multiplicity of 2 because of the x minus 1 squared. This is multiplicity of 1, so it just goes straight through. And this is your graph. The only piece that I'm missing here is the y-intercept. And the way we're going to calculate our y-intercept is simply by multiplying the constants in our function. So we have negative 1 squared, which is 1. 1 times 2, which is 2. So our function passes by y equals 2. And there's our function. So again, notice it's a cubic, so it starts down here, finishes up here, and the multiplicity of 2 makes it bounce right here. Okay, so the next one, we have our 0 at x equals negative 2, and we have a 0 at x equals 0. Okay, so we have x equals 0 is one of our zeros, and x equals negative 2 is the other. Okay, so this is where our two zeros are going to be. Put those in red again. Okay, so this is a quartic, so a power of 4. So when you see this function here, you should say, okay, there are 4 zeros, right? This one's just repeated 3 times. So 1, 2, 3, 4. Okay, and x to the power of 4 has a function like this that goes up, right? Or like this that goes down. Okay, so in our case, it's the one that goes down because it's the negative x4. So we know that we're going to start and finish going down. Okay, so at x equals negative 2, we're going to have the cubic form here, and we're going to cross 0 directly. So what our graph looks like would be this. So you'd have the cubic shape right at that 0, and then on that 0 it's just 1, so it goes straight across. And that would be our shape. So notice the x4 going down, that's where these two end up at the bottom. Okay, next one. So let's take a look at our zeros. We have x equals 2 is a 0, so I'm going to plug that in, 1, 2. And we have x equals 0 as a 0 because it's x times x times x, right? So if x equals 0, you'd have a 0. So those are only two zeros, okay? It's a power of 5 function, right? Because so we call that a quintic function, so power of 5. So an x5 function, so x5 function, right, will look like this if it's positive, and, oops, that's negative 5, would look like this if it was negative, okay? In our case, it's positive because all the factors are, the coefficient's positive, so we're going to have a finish and a start over here. Notice at x cubed, we're going to have this shape coming around that 0, and at x equals 2, because of the multiplicity of 2, we're going to have a bounce. So what the graph's going to look like, you're going to have your cubic shape there, and then you're going to have the bounce here, and there's our graph. And again, look, the x5 function, you start here, you finish there. Okay, last one. This is another quartic, so power 4, so 1, 2, 3, 4. And notice we have a negative here, so that means we're going to go to the bottom again. Okay, so we're going to start and finish over here. Our zeros will be x equals 1, oops, 1, x equals negative 3, so we have negative 3 there, and x equals negative 1. So those were the zeros going to be. So there, there, and there. Again, our zeros are coming from each factor. Notice that you will have a multiplicity of 2 here at x equals negative 1. So you're going to bounce from whatever side over here. Okay, and since we have a negative power 4, negative x4 function, which would look something like this. Okay, so which means that you must start and finish over here. We're going to start our graph. So at negative 3, you go straight through. At negative 1, you bounce. And at 1, you go straight through. And what we have is that. The only value I'm missing now is the y-intercept. Okay, and to calculate the y-intercept, again, all you got to do is multiply the constants. So 1 squared is 1, times 3 is 3, times negative 1 is negative 3, and times another negative 1, which is positive 3. So that's your 3. Okay, a couple things to note. The multiplicity of 2 and 3 has this distinct shape at the 0, right? So the cube, this shape here, and the square shape here. Again, this to sketch, you draw a half parabola one way, half parabola the other way. So multiplicity of 2 or anything even makes the graph bounce. The multiplicity of 3 or odd, other than 1, because 1 you go straight across, makes the graph shape near the 0 behave like a cubic. All right. Okay, so next thing we're going to look at is fractional zeros. So express the polynomial function in its general form. So this is the general form. So it's just expanded. So here are 3 factors. Notice that there's a 2 in front of the x here. And how is this going to change things? Okay, so first thing, let's expand it. Let's write it in the general form. So I'm going to multiply these two together. So the first 2 is going to be 2x squared plus 5x minus 3 times x minus 5 equals 0. And then when I expand all that, you're going to have 2x cubed plus 5x squared minus 10x squared minus 3x minus 25x plus 15 equals 0. And therefore, simplified, it's 2x cubed minus 5x squared minus 28x plus 15 equals 0. So all I did was expand that, right? So notice that this trinomial looks a little different with this 2 in front. Okay, so normally we would find all the possible factors of 15. So it would be plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Okay, but notice that those aren't the three factors. The 5 and the 3 are there, but this would be x equals to 1/2, right? If we were to find the zeros here. So when the value of a is not plus or minus 1, so when this is not plus or minus 1, to find all the possible zeros, you must divide d, or so in our case D, by the value of A. So you would have plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. You would also take all those factors and divide them by 2 to double the amount of zeros. Okay, so what does that look like? So let's find all the possible zeros of this function. Okay, well, so you would take 12, negative 12, and you would say, well, what are all the possible factors of 12? Well, we would say all the possible zeros, sorry. Okay, so it would be x equals to plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. So those would be all the possible factors of this trinomial. That's not considering this a here. Okay? So now, because of this 2 over here, this will double the amount of zeros here. You would take every single one of these and divide them by 2. So, I would take this 1 divided by 2. You would x equals to plus or minus 1/2. You would take 2 divided by 2. You would get 1. So that would be the same. You would take 3 and divide it by 2. So that means plus or minus 3/2 is also a possible zero. Okay? You take 4 divided by 2, you get 3. 4 divided by 2, you get 2. We already counted that one. 6 divided by 2, you get 3. We already counted that one. And 12 divided by 2 is 6, which we also have. So by adding this 2 in the mix, you've added these as possible zeros to the original lineup. So, knowing what we know, let's completely factor this trinomial. Okay, so we just found all the possible zeros, so we've got to find one that works. All right, so the first thing I'm going to try is I'm going to try plus or minus 1. So f of 1, that one's easy to find because it's just the constants put together, right? So, or the coefficients, sorry. So it'd be negative 3 plus 8 minus 12. This is not equal to 0. Okay, so we're going to plug in negative 1, which is also easy to try because this one becomes negative 1 times negative 2, which is 2. So all I'm plugging in is negative 1 for x's here, right? So then I plug in negative 1 here. Negative 1 squared is positive, so this is plus 3. You got negative 8 and negative 12. That is not equal to 0. All right, no luck for the ones. Okay, so maybe let's try 2's now. So f of 2. Okay, so again, I'm going to do some mental math directly in there. So 2 cubed is 8. 8 times negative 2 is negative 16. Plus 4 times 3, which is 12. Plus 16 minus 12. Ah, look at that. That is equal to 0. Check. We found our first 0. That's how we're going to do that. And then now we're going to take this 2, right? And then we're going to do our synthetic division. So I'm going to place all those numbers in here. So negative 2, 3, 8, and negative 12. So I'm going to extend this a little bit. And we're going to make our division. So the first thing you do is drop the negative 2. And then you multiply those two, which gives us negative 4. Subtraction. You multiply those two, gives us negative 2, which gives you 6. And you multiply those two, and it gives you 12. Perfect. Because the remainder is now 0, right? Which means this is a 0. So our function f of x will now be equal to the factor we found. So this is 1, 0. Therefore, x minus 2 is one factor, right? And then the remainder of this is over here. So negative 2x squared minus x plus 6. Okay, so now what I'm going to do with this, since this is negative, I'm going to factor a negative out of this. So what that's going to look like, you have f of x equals to, I'm going to bring the negative all the way up front. So you have negative in front here. This negative 1 multiplies everything. So that's the factor negative of here. So all these signs change. So plus x minus 6. Okay, so this just makes it a little easier to factor this. Okay, so now this factoring, okay, more practice factoring. If you haven't mastered this yet, please talk to me. You need to be able to do this. Okay, so we factor this. Okay, so this would be 2x and x. And now we are going to have plus 2 over here minus 3 there. So if you notice, this is negative 6. And then this would be negative 3 and plus 4. So together it gives you plus 1. Here are your factors. So notice x equals 2 is 1, 0. We had found that one. X equals negative 2 would also be a 0. And we'd also have x equals to 3 over 2. So that's the other 0. And notice that we have a factor of negative 1 in the front. Now, to sketch this graph, you would need it in factored form. So I'm going to place my zeros. Okay, we've already talked about it. So 2 and negative 2 are there. So 1, 2, and 1, 2. Those are our zeros. There's another 0 at x equals to positive 1.5, so 3 over 2. So you're going to have another 0 right here at 1.5. And notice that our cubic function, cubic because there are 3 factors, is negative. So the negative cubic function, right, so negative x cubed, looks something like this. So we know that our graph must start over here and end down here. So our graph must start here, right? Comes back around, it's going to bounce quickly and end there. And so again, start here, end there. All the zeros have a multiplicity of 1, so you just cross them all. Last thing I want to find is this value here. Okay, and that's a pretty easy value to find if you start with the original function, because that's just the constant. Okay, because if x equals 0, all those go away. This negative 12 is the y-intercept. So you plug in negative 12 here. Okay, if I wanted to find that using this formula, right, I'd just multiply all the constants together. So it would be 2 times negative 3, which is negative 6. Negative 6 times negative 2 is 12, times negative 1, which is negative 12. All right, good luck, and I'll see you in class.